All right, good morning. I'm not sure what happened to my layout, but I'm not able to pin myself and I don't know. Can you guys see me okay though, or no?
Yeah.
Do you see me as you normally do or no?
No,
No, you're like a little smaller.
Yeah, so I'm gonna have to call WebEx. I don't know. They changed something and I can't pin myself and I don't know. Um, I'm messing with it a lot. I've Googled it. I don't know how to fix it. Um, so you'll just have to bear with me. Let me know if you can't see something. Gonna open up the chat. Okay, so what I want to do today are two things. First of all, I want to go through lesson 7.1 and pretend like we're taking a quiz. So I'm going to give you a problem in each section and see if you can do it. We're not going to go into the teams. We're just going to, I'm going to give you the problem. I want you to do it on paper. So make sure you have a pencil and paper. And then I'm going to do it and just make sure we all know we're all on the same page. Okay, so if you guys can open up your books to page 818. And for Victor and Naomi, if there's any downtime, like if you finish a problem before everybody else can, I tried to change the link in the teams for team 3. Can you guys just see if team 3 now without me allowing access, and then send me a remind message saying you were able to get in? So I did try to fix it. I just want to know if it is fixed. Okay. So page 818. Now, the first objective that I taught was verifying a solution. So I want to do problem number 2. And what they're giving you is the ordered pair -3, 5. And they want to know, is this a solution to this system 9x plus 7y equals 8 and 8x minus 9y equaling -69. All right, so before we do this, can you guys just tell me what are you going to do to do this problem? How do you know? Hello? Okay, how do you know if this is a solution to the system?
You plug it in for X and Y.
Right, for each one. Okay, so go ahead and do that. And what I want you to do, I'm gonna take attendance. In the chat that I just opened up, I want you to write D for done. So you're writing D for done when you get the answer yes or no. All right? Cynthia is absent. Angel, Jaden absent. I got 3 people done. We're looking for 6 of you. Okay, waiting for 2 of you. Now, what you're actually doing here is you're verifying, and verifying is a proof. And so what you're doing is you're not solving, so you can't move things across the equal sign. You just have to plug in X and Y. So this would be 9 times -3 plus 7 times 5. Does that equal 8? Does -27 plus 35 equal 8? 35 minus 27 is 8. So the first one worked. Now that does not mean the second one will work. So you have to go to the second one and do the same thing. 8 times -3 minus 9 times 5. Does that equal -69? Does -24 minus 45 equal -69? Does -69 equal -69? Yes, it does. So therefore, yes, this is a solution. Okay, so that's the first thing we learned, is verifying if an ordered pair is a solution to a system. All right. The second thing we learned is solving by a method called substitution. So I'd like to do problem number 6. And they're going to give you a system, x plus y equals 6, and y equals 2x. Now, let me ask you, when you're solving by substitution, do you stack them or do you lay them side by side?
Side by side.
Right. And you're going to solve these. Guess what? It is already solved. So you're going to do 2x into the other one. And what you're going to do is you're going to come up with a solution, which is an ordered pair. Okay, when you're done, I want you to circle your answer and you're going to put a Y in the chat. So yes, you're done. Put a Y in the chat when you're done. Did you guys get x equals 2?
Yes.
Yeah.
All right. And so after you do that, you have to find the Y, right? So what's your answer?
2, 4.
2, 4, X, Y. Okay, let's do another one. So let's do number 10. You're going to solve by substitution. And the linear equations are x equals 3y plus 7. And the other one is x equals 2y minus 1. So once again, don't forget to write them side by side. And you're supposed to solve for the easiest variable. We'll look up here for a second. This is already solved for x. So you can either put that into x over there, or you can put this in for x over there. It doesn't matter what you do. So you can either substitute this way, or you can substitute this way. You're going to get the same answer. When you're done, put a done, D-O-N-E, in the chat when you're done. So put D-O-N-E in the chat when you're done. So if you substitute that way, you're taking out the x and putting that 2y minus 1 in. You take the x out and put the, what it's equal to in there. So you can solve for y. So if you subtract 2y, you get 1y plus 7. If you subtract 7, you get negative 8. Is that what you guys got or no?
Yeah, I got that.
So now you can substitute this in for y over here. X is equal to 2 times negative 8 minus 1. X is equal to negative 16 minus 1. X is equal to negative 17. So what's your answer then?
Negative.
Where are the two lines intersecting? What is it?
-17, -8.
That's correct. Now, only a few people said they in the chat. So do you guys want to do another one of these or not? I mean, I don't know what the hang up is. You either get it or you don't. If you don't get it, we can do another one. So please speak up. Do you want to do another one or not?
Yes.
Okay.
Yeah.
Do another one? Okay. Let's do number 12. So it's 4x plus 3y equals 0. 2x minus y equals 0. So you're going to write them side by side. And you're going to solve for the easiest variable. And the easiest variable is that. So you're going to solve for y in terms of x, and then you're going to substitute into y over here, and don't forget to distribute. Okay, when you're done, put a y in the chat saying you're done. So when you're done, put a y in the chat. All right. So it looks like we had more people that time. So this is 4x plus 6x equals 0. So 10x equals 0. When you divide by 10, a 0 in the numerator is always 0. So when you substitute this back in for x, you get 2 times 0, which is 0. So your ordered pair is 0, 0. Okay, do you guys have any questions about solving using substitution?
No.
All right, let's solve using addition now. So now when you solve with addition, you stack it to eliminate a variable. So let's do problem number 20 first. So number 20 is x plus y equals 6. And the other one is x minus y equals -2. So you're going to stack it and eliminate a variable. Then you're going to go back and find the other variable. And in the chat, you're gonna type the word yes when you're done. Okay, you should be done with the problem. So I'm not sure what you're doing, but you should be done. So x plus x is 1x plus 1x is 2x equals 4. Divide by 2, x is equal to 2. Substitute into one of them. So that would be 2 plus y equals 6, y equals 4. So your ordered pair is 2, 4. Right, right. Okay, let's do another one. It's really easy. Just stack it, eliminate a variable, solve for the other one by adding. You always add x equals 2, plug it into one of those, and get the ordered pair. All right, so since no one typed yes in the box, we'll type yes again. This time we'll do problem number 22. I mean, the reason why I'm upset is this is due tonight. We don't know what we're doing. It's due tonight. Should already be done with the assignment. 3x plus y equals 14. 3x minus 2y. And you can probably guess why I wanted to teach this. This is really testing out, can you maneuver with algebra? So that's one of the reasons why we're doing this set of problems, because I want to know, can you handle the algebra? So solve for x, then go by and find y. Type yes in the box when you're done. Naomi, since you're done, can you do me a favor and see if you can get into team 3 in the Math Wizard team and send me a remind? This is better. Okay, we have 4 people. We're missing 3 people, so we're missing half right now. So the half the class. Perfect, thank you so much. Okay. So 3x plus 3x is 6x, and that's equal to 24. So when you divide 6, x is equal to 4. Now you pick one of those to substitute into. I'll pick the top one. It'd be 3 times 4 plus 2y equals 14. Solve for y. 12 plus 2y equals 14. So 12 is 1. So what pair? What's your solution where the two lines are intersecting?
4, 1.
4, 1. Thanks. So make sure you always write the ordered pair. It's not good enough to just write x, y. You're giving the ordered pair where the lines are intersecting. That's the solution. You must write that. Okay, let's do a harder problem where they don't automatically cancel. So in this problem, you're going to have to manipulate one or both of the equations to make a variable cancel. So let's take a look at number 24. You have 2x minus 7y equals 2. And you have 3x plus y equals negative 20. So see, if you add the x's, it's not going to go away. If you add the y's, it's not going to go away. So tell me what you think you're going to do on this.
You're gonna find a common number that the x or y multiply to.
Right. So do you think you guys, do you think you want to get rid of the x or do you think you want to get rid of the y? Which one looks easier?
The y.
The X.
Right. Okay, it's the y. And the reason why is because if we multiply this equation by 7, we're going to be able to add and eliminate the y's. If you try to get rid of the x, you would have to multiply this guy by a negative 3 and this guy by a positive 2 to get true opposites. So you would have to get like a negative 6 and a positive 6. So the x's are actually going to cause more work. So what you want to do when you stack this, leave this guy alone and multiply everything on the bottom by 7, and you'll be able to eliminate the y's. When you're done, put a D in the chat. When you're done, put a D in the chat.
Miss Birch, how did you get the 33?
Oh, it should be 23, right?
Yeah.
Thanks. Did you guys get -6, -2?
Yeah, I got that.
Jaden, Paige, you guys get -6, -2?
Yeah.
Jerry, you out there?
Yeah, I got that.
Naomi?
Yeah.
Okay. Okay, so we verified that in ordered pairs of solution, we solve by substitution, we solve by addition, also known as linear combinations and elimination. And the last thing I taught yesterday was what happens if you lose the variable? Well, if you lose the variable and you get a false statement, no solutions. If you lose the variable and get a true statement, infinite solutions in that. So let's do number 32. Okay, now they say to use any method that you want. So you tell me, do you think we should stack them and use addition, or do you think we should use substitution?
Substitution,
Yes, you're right. Why?
because the y is already solved.
Yes, because the y is already solved. The easiest variable is already solved in terms of x. So you do want to use substitution. All right, so go ahead and you're going to either give me an answer of infinite solutions or no solutions. And put a in the chat when you're done. So you lost the variable, right? Is this true or false?
False.
False.
And what does false mean?
No solution?
No solution.
Yeah. So I'm going to show you 3 ways that the test might do it. Make sure you work the online problem so you know it could either say no solutions. It could straight out write no solutions. Or it might be the empty set like that. So normally when students have me for the first time, some students like to write their zeros like that. And the reason why you don't write your zeros like that is because that means null. And that means no solutions. Now on this exam, I'm not sure what it'll do one of these 3. So you should know all 3 of them, depending if you're taking the SAT or this test or a test in another class. All 3 of these mean the same thing. All right, let's do problem number 34. You can use any method of your choice. The system is 9x minus 3y equals 12. And I'll tell you right now, I would divide everything by 3. The other equation is y is equal to 2 minus, no, 34. Equals 12, y equals 3x minus 4. So you're going to use substitution again. Before I do that, I would divide this by 3. That's what I would do. Okay, when you're done with this, type in done. So you're being asked to solve this. You can use elimination or substitution. I would simplify this one. So you're going to make sure you distribute. So this would be 3x minus 3x plus 4 equals 4. So what do you get? Is that true or false?
True.
And so watch how they write the solutions. They write it a special way because it means infinite solutions in that system. So let me show you how they write it. They write it like this. The ordered pair xy such that it's this. So in other words, both of these equations are y equals 3x minus 4. It's the same equation. And any ordered pair that works in here will be a solution to the system. So like if you have x equals 1 and y equals -1, that will work. If you have x equals 0 and y equals -4, so there's infinite solutions in the system. And this is how they write it. And like I said, this comes from this. If you solve for y, you're going to get these are the same equation. Infinite solutions in the system. All right, anybody have any questions about no solutions or infinite solutions? All right, well, I want to teach part of 7.2 today, and it's exactly like this stuff, but instead of having an ordered pair, you're going to have an triple because we're going to have 3 variables now. So this is lesson 7.2. And in 7.2, we're looking at systems in 3 variables. And our solution is going to be an ordered triple. So instead of X and Y now, you're going to have X, Y, and Z. And what this means is we're in 3 dimensions. And so we had to graph something. The x-axis looks like, I'm sorry, the x-axis looks like that. Hold on. It looks like a corner of a wall. So you have an x-axis, a y-axis, and a z-axis. And you're in 3 dimensions, and it is difficult to graph. So we're going to do the same thing, though, that we did before. Given a system of equations in 3 variables this time, you would have x plus 2y minus 3z equals 9. You would have 2x minus y plus 2z equals -8. And you would have negative x plus 3y minus 4z equals 15. And they want to know, is this order triple x, z a solution? So what I'd like you to is I'd like you to take each one of these and plug in x, y, and z and tell me, is this a solution or not? It has to work in all 3. So I'm going to do it, but I want you to I'm going to give you a couple minutes to get started on this. Take each one of them and plug in the ordered triple and tell me if it works or not. All right, did you guys get the first one to work?
I got it. Yeah.
All right. Let's continue with the second one. It's a -8. Did you get the second one to work?
Yeah.
Okay, now I've actually seen it work on the first two and fail on the third one. You do have to check it. Did you get the third one to work?
Yeah.
So yes, -1, 2, -2 is a solution to the system. So just like this is more work, solving is going to be more work. So I'll show you how to solve this. Make sure you take good notes. And if you have any questions, make sure you ask me. All right. So this is solving. So this is going to be 5x minus 2y minus 4z equals 3. 3x plus 3y plus 2z equals -3. I'm looking to see if I can simplify any of these. So far, no. -2x plus 5y plus 3z equals 3. And so let me just tell you what you're trying to do. You're trying to make two pairs, which means you're going to have to reuse one of these. And in addition to that, you're trying to eliminate the same variable in both pairs. So I'm going to eliminate z because I'm looking at this and I don't know, big mess. So what I'm going to do is I'm going to put the first two together. And I'm going to eliminate the z in a minute. And I'm going to put these two together. And I'm going to eliminate z in that one also. So I'm reusing the second one. Now, in both of these, I'm going to have to do some work. So this one's not so bad. I can multiply the bottom by -2 to get the z's to eliminate. So let me show you. So the top one stays the same. The bottom would be -6x minus 6y minus, I don't want negative. I want a +2. Sorry. So let me do it again. I want a +2 because I'm trying to get opposites. So this would be a +6x, a +6y, and a +4z and a -6. So that's how I'm going to eliminate the z on that one. Over here, you have to eliminate the same variable. So make a note, you must eliminate the same variable. Like, for example, you can't eliminate an x in one and a y in another, it won't work. So over here, we're still focused on the z. So I'm going to multiply the top by a +3, and I'm going to multiply the bottom by a -2. So I'm trying to get a +6 and a -6. So on the top, I get 9x plus 9y plus 6z when you distribute equals -9. And you get a +4x minus 10y minus 6z equals -6. And I eliminated the z. So if you're wondering what I'm doing, I'm trying to eliminate a variable to get less than one system in two variables. So what happens here is when you add these, you get 11x plus y equals -3, which is correct. And over here, you get 13x minus y equals -15, which is correct. So now we have a system in two variables. I'm going to use a different color. And so basically, all that work we just did was for lesson 7.2. Now we're back to lesson 7.1. So you have a system in two variables, 11x plus 4y equals -3. And you have 13x minus y equals -15. And now you have to decide, what do you want to eliminate? And I'm going to use addition, and I'm going to multiply the bottom by 4 and eliminate y. So we get 11x plus 4y equals -3. And on the bottom, when I multiply by 4, I get 52x minus 4y equals -60. So finally, I can find x. So this is going to be 63x equals a -63. X equals -1. So all that work just to find x, I still have to find y and z. So to find, you can't plug into the original. You got to plug into one of these to find y. So I'm going to do the top one. 11x plus 4y equals -3. Plug in a -1. 11 times negative plus 4y equals -3. -11 plus 4y equals -3. Add 11. Add 11 would be 8. Y equals 2. So now, as you may have guessed, we have to plug into one of the original ones, find the last variable. Pick the middle one, just plus 3y plus 2z equal to -3, and plug in your x, plug in your y, and for z. So this is going to be -3 plus 6 plus 2z equals -3. 3 plus 2z equals -3. Subtract 3 2z is equal to -6, z is equal to -3. And so we're finally done. And we want to write triple. It's going to be x, y, and z. Okay, that is the correct answer. If you notice, I tried to keep things really neat and organized because obviously I don't want to make any mistakes. This problem is too long. I do want you to know in this lesson, I didn't assign all the problems, I assigned a few because of the length of the problems. But let me reiterate what I said. The first thing, beat one of these. Doesn't matter what. You're going to eliminate the same variable in both and get a system of equations in two variables. After you do that, you're going to use either substitution or addition to two variables. And when you're done, you're going to substitute those two back into one of the originals to find the ordered triple. It's weird because a lot of students take an interest in this lesson. I think because it seems like it's like a puzzle, like, can I do it? Can I find the ordered triple? So a lot of people, more than usual, do this assignment, which is weird to me, but yeah. So if you have your book, and you can look on page 824, when we're in 3 dimensions, the line turns into a plane. So if you look in the middle of page 824, you see that point of intersection? That's what we found. We found out where 3 lines in 3 planes intersect at a point. And that's the point. All right, anybody have any questions? Another problem together, just to make sure you can set it up right. Anybody have any questions about this?
You said we had to eliminate the same variable, right?
Yeah. So in this, I eliminated z and z, but it doesn't matter what you could pick y and y or x and x. Just don't eliminate a z and an x. That it will not work that way. So you're either going to eliminate a z in both, an x in both, or a y in both. Do you understand what I'm saying?
Yeah.
So let's set up another problem. So let's set up one in your book. Let's set up numbers. I'm on page 829. So we have 2x plus y minus 2z is equal to -1. 3x minus 3y minus z equals 5. Let's see if I can simplify any of these. So far, no, so not so good. X minus 2y plus 3z equals 6. And now we just want to look at this for a minute. And what variable do you want to, we can eliminate an x or y or z. None of them look really hard. Let's eliminate, doesn't the y want to eliminate the y this time? And we can reuse this one. This one looks really good to reuse. So if I take 2x plus y minus 2z equals -1 and put it with the second one, I could eliminate the y's easily by multiplying the top by 3. If I take the top one with the third one, I can eliminate the y easily by multiplying the top by 2. Do you see what I'm saying? Can you guys respond, please?
I'm a little confused.
Well, okay, when I pair these up, I can multiply the top by 3 and eliminate the y easily. I can multiply the top by 2 and eliminate the y easily.
Oh, okay, I see what you mean.
So I'm going to multiply the top by 3. You get 6x plus 3y minus 6z equals -3. The bottom stays the same. And see how I was able to eliminate the y? In this one, if I multiply the top by 2, when you distribute, you get 4x plus 2y minus 4z equals -2 and leave the bottom alone. So see how the y's are going to go away? Yes or no?
Yes.
So what you get is 9x minus c negative equals 2x minus z equals 4, and that's your system of equations in 2 variables. So over here in the orange, your system in 2 variables will be 9x minus 7 equals 2 and 5x minus z equals 4. So now we're back to lesson 1 again. Do you want me to just keep going and finish this out?
Yes, please.
Okay. So this time I'm going to eliminate the z because I can multiply by a -7 and make that a +7. So I'm going to use elimination. So I have 9x minus 7z equals 2. I'm going to multiply the bottom by a -7. A -7 would make it positive, and a -7 would be -28. So I can eliminate the z. Just follow that? I multiplied the bottom by 7, -7. So now we get a negative, what is that? 26 and a -26. So x equals 1. I'm going to substitute back into one of these to find z. So I'm going to do 9x minus 7z equals 2. So 9 times 1 minus 7z equals 2. 9 minus 7z equals 2. Subtract 9. When you subtract 9, you're going to get -7. So Z equals 1. So now you found X and Z. Now we go back into the original, and you can pick any of these you want. I'll just pick the top one. You have 2x plus y minus 2z is equal to -1. So you have 2 times x plus y minus 2 times 1 equals -1. You have 2 plus y minus 2 equals -1. Y equals -1. So your ordered triple is 1, -1, and 1, and that is the correct answer. So once again, you want to have 2 pairs of equations, and in the last problem, you eliminate z in both. Now you saw me eliminate y in both. So after that, this is all this right. Lesson 1, you have a system of equations in 2 variables. You can use substitution or elimination. I chose, addition. I chose addition. So I multiplied both sides by -7, and I found x. After I found x, I plugged it into one of these two to find z, and the final one, these have to be plugged into one of these to find the ordered triple. All right, now I have one problem to show you with this, but otherwise I'm done with the lesson. This lesson's due next week. Actually, I haven't made a due date on this yet. I have not made a due date on this, but I only have one thing to teach. So lesson 7.1, you should be done with it. We're almost done with it. I gave you 4 or 5 days to do it. So you should be starting on this lesson. Every time I teach a new lesson, you should be starting on the lesson that I'm teaching. Shouldn't be waiting last minute to do an assignment. That's a good way to stay behind all the time. All right, anybody want to ask me about this? All right, if you want to hang out, you can. Otherwise, yeah, enough is enough. So guys, have a good day. All right, have a good day.